Hi everyone, I'm Sicong. Today I'm going to talk about the privacy adversarial network. It's about how to learn the representations for mobile data privacy. This is a joint work with Rice University. Today, machine learning has benefited a lot of mobile services such as the Siri, Amazon. And mobile users are always required to upload the voice, image, video, and other raw data for intelligent services. But sending raw data to the mobile service provider presents serious challenges to the user's privacy. For example, the mobile user says, "Hi Siri." There is a risk of disclosing the voice privacy. Towards addressing this challenge, our key insight is that most services actually do not need the raw data. Our goal is to avoid disclosing raw data to service providers by creating a device local intermediate component that encodes the raw data and only sends the encoded data. So in this way, the encoded data must be useful and private. However, existing solutions struggle to balance the seemingly conflicting utility and privacy objectives, such as the widely practiced noisy data, task pricing, specific feature, and hybriding feature. Unlike the previous work, we want to automatically learn the deep features to find a sweet trade-off between the utility and the privacy. In this work, we want to maximize the utility. This is quantify the inference accuracy and maximize the reconstruction error. This is used to quantify the agnostic privacy and minimize the inference accuracy of some private attributes that is used to measure the user's specified privacy. But when we use the Sicong to learn features by maximizing the task inference accuracy, the reconstruction error are always small. And when the autoencoder learns features by minimizing the reconstruction error, which conflicts with our objective. So we focus on the training of the encoder by introduce a new deep model, the PAN. It employing a utility discriminator to as the positive teacher to supervise the training of the encoder, and employ the adversaries to confront with the training of the encoder. And we hope a powerful encoder must come from a tough teacher and two powerful adversaries. So we present a new training algorithm of PAN to avoid the model degradation. Using digit recognition, image classifications, sound sensing, human activity prediction, and the driver behavior recognition, we evaluate the performance of PAN. And we train two types of PAN. The PAN 1 is trained with one attacker, and the PAN 2 is trained with two attackers. And we compare the PAN's performance with the other four baselines. We can see that the PAN can achieve the best utility privacy trade-off, and the PAN 2 also achieve the best trade-off, and also the utility of the PAN's encoder output is even better than that of the standard DNN. We further visualize the PAN to seek how Sigma inside how does the PAN disentangle the feature components relevant to privacy from those relevant to utility. We can see that the PAN push the features towards more constrictive space, and this space is dominated by the samples without redundant private sensitive background information. And we also visualize the PAN's encoder output on the reconstruction privacy. And finally, we also provide a manifold learning-based interpretation for better utility and privacy performance of PAN's encoder output. We think PAN is a framework. It can further accommodate more choices of the utility and privacy quantification and integrate more utility discriminators and privacy attackers, and also more insights to guarantee and accelerate training convergence of planning are needed. Thank you.